Welcome to the Chemistry, Biology and Math Revision Hub. Today we are doing the Pearson Edexcel International GCSE Chemistry Paper 1C for June 2022. This is the part 1 video. I will do 2 more videos and put their links in the description box. So let's begin with question 1. Question 1 says the diagram shows the electronic configuration of an atom of an element. So here we can see, here we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. There are 11 electrons. So they say, name the part of the atom that contains the proton and neutron. So the protons and neutrons are contained inside the nucleus, so they should be nucleus. The next part says, give the number of protons in this atom. If this is an atom and it has 11 electrons, it means it also has 11 protons. Remember, they told you this is an atom of an element, so it means this is in its elemental state. So the number of protons should equal to the number of electrons, so this is 11 protons. The next part says, give the number of the group that contains this element. Since it has one electron in the outer shell, it should belong to group 1. The next part says, give the number of the period that contains this element. We can see, if I go back to it, this is the first shell, the second shell, and then the third shell. Each shell is representing a period, so I can see those. This belongs to period 3. So the next part says, give the charge on the ion formed from this atom. When this atom forms an ion, meaning a fully filled outer shell, it will lose 1 electron, and therefore it will have a +1 charge on it. This is the end of question 1. Let's continue to question 2. Question 2 says, the box shows some changes of state. So here we can see there is boiling, freezing, melting, condensation, evaporation, and sublimation. They say the table lists some physical properties. Complete the table using words from the box to show the change of state for each physical change. When water is converted into ice, this is a process of freezing. A liquid is converted into a solid, so that is freezing. When steam is converted to water, we are turning a gas into liquid. This is condensation. When solid works is converted into liquid works, this is a solid being turned to liquid, it's melting. And when iodine crystals turn to iodine vapor, solid directly to gas, this is sublimation. So moving on, it says, a student plans to obtain salt crystals from a mixture of salt and sand. The student adds pure water to the mixture to dissolve the salt. State 2 things the student could do to make the salt dissolve quickly. If you are to make the salt dissolve quickly, increase the temperature and then you can stir. So heat the mixture and then stir. When you increase the temperature, you increase the ability of this substance to dissolve, and then stirring ensures that the temperature is uniform, and then it's that agitation causes the solid to dissolve even more. The next part says, state what the student should do to separate the sand from the salt solution. You're separating a sand, something that cannot dissolve, from something that is dissolved or a solution. You need to filter. Filtration will be able to separate an insoluble solid from a solution. So let's move on. This part says, describe how the student can obtain pure dry crystals of salt from the salt solution. If you want to obtain pure dry crystals from the salt solution, it means we need to begin by heating the salt solution. Remember, this salt solution, they have filtered it to remove the insoluble substance, which is the sand. The remaining part contains a little bit excess water, so we begin by heating the solution to evaporate off some of the water. This ensures that the crystallization point is reached. This is a point where the crystals begin to form on the stirring rod. If you are using the stirring rod, you see some crystals begin to form. And then after that, you will stop the heating and leave it to cool so that the crystals begin to form more. And then after, when the crystals are formed, you will filter to obtain the crystals. And finally, you can dry the obtained crystals in an oven at low temperature, or you could dry them using a desiccator, or you could dry them using kitchen towels. So the drying, the method you use to dry depends on how dry the samples you want the samples to be. If you want them for a shorter period of time, then an oven could be more efficient than a desiccator, because the desiccator is going to slowly suck out the water, but it will give you the same ability to dry the crystals as would an oven. An oven, you have to make sure it's at low temperature, because if it's at high temperature, then some of the crystals can break down, or they can be able to disintegrate into other compounds which you did not intend to make. So this brings us to the end of question 2. Let's continue to question 3. Question 3, crude oil is an important source of organic compounds. The diagram shows how crude oil can be separated into fractions by fractional distillation. Here we can see crude oil enters here, where it's heated, and then it's separated into different fractions based on their boiling temperature. So the first question here says, state what happens to the crude oil when it is in X. Crude oil is heated when it's here. The next part says, give the name of fraction E. Fraction E is gasoline. So that's it. And then give use for fraction A. Fraction A is bitumen, and this is used in roofings as well as in roads for tarmac. Tarmac used for on the roads or in road construction. So moving on to the next part. Here they say one of the compounds in fraction D is tridecan, which can be cracked to form shorter chain hydrocarbons. State the catalyst and temperature used in this cracking reaction. The catalyst here we can say silica, which is silicon dioxide, alumina, which is aluminium oxide, or you just have zeolite, which is a mixture of silica and alumina. So any of those, you could get the answer right. And for the temperature, it should be between 600 to 700 degrees Celsius. The next question says, the equation shows an example of a catalytic cracking reaction. So here we can see an alkane is broken down into an alkane as well as two other alkenes. So they ask, give 2 reasons why this reaction is important. Here we can see that an alkane, which is a longer carbon chain alkane, is converted into a smaller carbon chain alkane as well as alkenes. These alkenes can be used in formation of other organic molecules, including polymers as well as alcohols, halogenoalkanes, and so on. While this alkane can be used as a source of fuel because it can be easily burned, so I said it produces an alkane and shorter chain alkenes. Shorter chain alkanes have more, here they have more uses, which is meaning they are higher in demand as fuels. And the produced alkenes can be used to make more organic compounds like polymers, you could say alcohols, halogenoalkanes, and so on. The next part says, sulfur is an impurity in crude oil. Explain why this is a problem for the environment. When crude oil contains sulfur, it means the produced fuels, or let's say gas or anything, is going to contain these sulfur compounds. And that means when they are burned, sulfur dioxide is going to be produced, as you can see here. And the produced sulfur dioxide can react with oxygen in the air, producing sulfur trioxide, which later reacts with water in the rain to produce sulfuric acid as acidic rain. Or the sulfur dioxide itself can directly react with the water in rain, producing sulfurous acid. So this can produce acid rain when the SO2 reacts with water in the rain. So this brings us to the end of question 3. Let's continue to question 4. Question 4 says, a student uses the reaction between iron and oxygen to find the percentage of oxygen in air. The diagram shows the apparatus the student uses. So here we can see there is a flask they're using here, there is wet iron powder, and there is air. They are using powder to ensure that the surface area for this reaction is really large. And then we can see the oxygen, the air, which is in here, as well as there. So they say, state why the iron powder needs to be wet. It needs to be wet because water is a requirement for rusting to occur. And then the next part they ask, state, let me make this a little bit smaller. They say, state the color of the compound formed in the reaction between iron and oxygen. When iron is rusted, or when it's turned into iron oxide, it's going to be brown in color. Iron trioxide, which is this one here, they say give the formula of the compound, it's iron trioxide. And next they say explain the advantage of using iron powder rather than pieces of iron. This is easy. Iron powder provides a larger surface area, that is one point, and then the reaction, which is rusting, is going to occur more quickly due to this provided large surface area. So let us continue. Here they say the syringe in the diagram shows the rating at the end of the experiment. They say complete the table 1 to show the rating on the syringe. Give both values to the nearest 1 centimeter cubed. I want to take you back so that you can see the rating from the syringe. Here we can see there is 10, I think 11, 12. It's about let me 16, about 16 centimeters cubed. So coming back this side, we can see syringe reading at the end is 16 centimeters cubed. Now, if the change in volume is 65 and at the end it's 16, it means at the beginning it should be that plus that, which gives us 81 centimeters cubed. The next question says, the student repeats the experiment and obtains a different set of results. The table 2 shows these results. So we can see the volume of air in the conical flask and glass tube in centimeters cubed was that. And then the syringe reading at the start was that. And the syringe reading at the end was 22 centimeters cubed. So here they ask, use the results from table 2 to calculate the percentage by volume of oxygen in the air. So for me, what I did is I added up the initial total volume and the final total volume. So initial total volume is that plus that, which gives us 350 centimeters cubed. And then the final total volume should be that plus that, which gives us 282 centimeters cubed. That means the difference between that and that is the volume of oxygen used. So it should be 350 minus 285, which is that. Or you could do the difference between these two. That could also give you the volume of oxygen, like you can see here. 90 minus 22 gives you 68 centimeters cubed. Now, to calculate the percentage by volume of oxygen should be here the volume of oxygen divided by the total volume times 100, which gives us 19.4286. And again, here I kind of rounded it off to make it 19.4% to be more precise. So this brings us to the end of this video. Please do not forget to subscribe. See you in the next video. Bye-bye.